There are two basic rules for probability. And one is a multiplication rule and the other is the addition rule. The multiplication rule is talking about when we're talking about and instead of or. Okay, we're going to use the multiplication rule. So if A and B are two different events, then A and B, we're going to have that multiplication come in, equals the probability of B times the probability of A given that B has happened. Now that always is true, independent or dependent. If they are independent, then we don't really have to have that A given B because they don't have any relation to each other. So the formula at the bottom, if they are independent, it's simply the probability of A and B is just simply multiplying the two probabilities together. What this one here is talking about mostly is about if they are dependent, or if we don't know, then we will use this other formula, which is simply stated the probability of A and B divided by the probability of B. It's just if they are dependent, because one might put the cookie back in the cookie jar and one might eat the cookie. Independent or dependent events. When we use and, we're talking about or. A or B happening now. Think about either A or B. I have a larger group. I'm adding them together, then there's not any division here. Might be some subtraction. I have to subtract maybe where they are overlapping. But the definitions are on this slide. If A and B are defined on a sample space, then A, probability of A or B, is the same thing as the probability of A happening plus the probability of B happening, but I have to subtract out that overlap. There was an example given in a former textbook of families that went to Disney and Busch Gardens, and those that went to both. So if I were just to add all those probabilities together, I would get more than one, right? More than 100%, because I would be including those families that went to both parks. So that's why I have to then subtract out that A plus B, then I get the fuller picture. So that's what that is all about. That's why there's a subtraction there. Hopefully that makes some sense. Here's an example. This is in your book on page 189, so I'll let you look at it goes through every single piece of this. That's my face is in the way, of course. But Carlos is playing soccer, and he makes 65% of his goals, and he's going to attempt 2 goals this time in the next game. And so how likely is he to get both of those goals? Now, those might sound like they are independent events. Whether he makes 1 goal does not necessarily determine anything about the other goal, but he does shoot in streaks. We have this little bit of information that is important, because that means that A given B is going to be a little bit different than just the probability of A or the probability of B. So since he has that streaky shooting, we have that contingency there, and we have another probability to figure in. So you have the probability of A, and we have the probability of B, and we have the probability of making the second goal given that he made his first goal of 0.9. So in your book, check out the solutions for that and work through these problems. I think that will help you understand this contingency kind of idea. Another problem that is in your book as well on page 191 is talking about a student at a junior college, and she enrolls in a math class, or has a probability that she enrolls in a math class is 0.2, and probability she enrolls in a speech class is 0.65, and that sounds about right. People usually avoid taking that math class. The probability that she enrolls in a math class, given that she's enrolled in the speech class, is 0.25. So again, working through those, looking at the terminology, the notation, the answers are there on page 191. I think this is an important exercise to work through that to understand how those things fit together. Contingency tables we talked about in one of the other areas this week. And this is a nice contingency table because it actually totals. You notice at the bottom we have the totals, and on the side we have the totals, so that I can more easily pull my probabilities out. If I can take this number, I don't have to add up, I can just take it out of the total of those that do stretches. Injured last year, did stretches, right there I've got that contingency. So a table is a good way to lay it out. It helps it to stay in some sort of order, which helps us. And if we were looking at last year, injured and no injury, then we would be looking down and using those same totals here and the same pieces as we look down. There's a contingency table in the next one for you to fill out. This is example 3.21 in the book. And notice that when it tells us in the information that there are 100 hikers, I can then fill out the entirety of this table because I know that the total hikers has to add up to 100. So therefore I have the male hikers already, and I can subtract this, and I get this to equal this, and the whole table can be filled out, which I think is important exercise to go through and do. So, just on scratch paper, just eyeball it, make sure you understand how you would fill out that contingency table. Good luck. Lots of information this week.